The funny thing about the drug business is you have to constantly reinvent yourself because your drugs go generic. And that makes it very hard to build a business for the long run that actually has brands and things like that. It's rather just, frustrating building a drug company because there's a life cycle to every drug. And that life cycle means that all of these drugs will one day sort of come and go. And when we look at the model, which you can just sort of put together through the 10Q, their biggest drug right now is called Eliquis. It's a blood thinner, sometimes called apixaban. And apixaban is a great drug, but it's going to go generic soon. And that means that there'll be no profit left once it goes generic. There we go. I want to double check some of these numbers, but the next biggest drug is called Opdivo. Opdivo is a great cancer drug, but again, at some point there'll be a biosimilar. Pills go generic, and when a pill is generic, it means that any company can make it and make it for rock bottom prices. So generally, pharma companies lose 90, 95, maybe even 99% of their revenue from that drug when the generic drugs hit. In biological drugs, which are not pills, but they're antibodies, and they look very different. In fact, let's take a look at exactly what I'm talking about. I'm going to show you the molecular structure of apixaban. And here it is. It's a pyrazallopyridine, I think. Pyrimidine or pyridine? I always get those two confused. You can see its physiochemical properties. This is a website called PubChem. Not a lot of people use PubChem, but it's kind of cool little website. And like I said, it's used for blood thinner. It sort of was a better warfarin. Pyrazallopyridine. So there's the pyrazole and the pyridines here. This is a heterocyclic ring. And Bristol Myers did this drug, I want to say by themselves. Or no, they do it with Pfizer. They sell it with Pfizer. That's right. And I think it was a Bristol drug invented and then Pfizer sold. So anyway, this drug is very easy to make. In fact, you can give this to a chemist, and a good chemist can say, okay, I can make this in 4 synthetic steps, or whatever it is, and I need a pyridine, I need a carboxamide, I might need a piperidine, and I'm going to do these substitution reactions, and eventually I'm going to get this drug. And with a really good chemist, you want to minimize those steps, but the point is it's going to be really cheap and anyone can sell it. You have to spend about $2 million to be able to sell it. You have to do a human study that shows that the blood levels of your apixaban is the same as the blood levels of the real apixaban. But once you satisfy that, you're basically good to go. And you even have things like, here's the mass spec trace, and it's very easy to see the peak levels there. And it really isn't hard. You even have vendors here where you can buy the raw material and then do your own trial and see if you can get apixaban sold. And you might make money, and that's how small drug companies generally start. They start making generics. But apixaban will go generic, and it will no longer really be a Bristol Myers drug. The revenue will drop from several billion a quarter, which is enormous, to some very low number, maybe 10 or 20 or 30 million a quarter. So that's just something to keep in mind. And timing for that patent cliff is what we usually call them, is something we have to think about and look at very carefully. Drugs like Opdivo, this is a drug called nivolumab. If I wanted to show you the chemical structure, it's going to look very, very, very different. And the reason is it's a very large molecule. This is kind of what it looks like. this massive, massive molecule. So if you were to think about the drug I just showed you, apixaban, fitting in nivolumab, it might be just right here, just this little tiny piece. So by comparison, it really is a gigantic amount of molecules, and there's no way to fully, and this is just the Fab fragment, the entire molecule is even bigger. I was wondering, is this a single chain? I didn't think it was a single chain. But the Fab fragment is just one piece of it. The entire antibody looks like this. And you can see the Fab fragment here. But there's also this constant. This is FC, is fragment constant. And this constant region is very large as well. So you basically have this huge, humongous drug, maybe 100 times bigger than a small molecule. And there's no real way to do mass spec on that and understand that it's exactly the same. So what we have is something that's evolved for 25 years called the biosimilar framework. And biosimilars are a lot like generics, so they also will tank your sales. Here's another drug from Bristol Myers called Revlimid, and this used to be one of the biggest drugs in the world when it was part of a company called Celgene, a very legendary biotech company that merged with Bristol Myers. And Celgene's drug, Revlimid, is going off patent. And so revenue is declining very rapidly for Revlimid. But it's a very unique drug, so it's not going to fall off a cliff the same way I described earlier. Pomalyst is a lot like Revlimid. It's almost the same drug, in fact. I can show you the structures differ by very little. Yervoy is an antibody, so it has a bit of a different expiry profile. So I'm just ordering these by revenue because at the end of the day, what are we trying to do here? We're trying to analyze every single medicine and understand where's the revenue and earnings for Bristol Myers going to come from. Well, we might as well start with the biggest drugs and work our way down. And then we can also start with the pipeline, which are drugs that are not yet approved but will be, and see if any of those are going to be big sellers. So Reblozyl is a really interesting drug, sotatercept, that, is it sotatercept? Do I have that right? I don't think it's sotatercept, actually. It's from the same company that makes sotatercept, but it's luspatercept. And luspatercept is a really interesting fusion protein. And it's a new drug, so it's very unlikely to go generic anytime soon. It's probably going to be one of Bristol's biggest drugs in the long run. And it was from a company that I used to own some shares of called Acceleron, which was an amazing company. And Acceleron was bought out by Merck for sotatercept, their other drug. They should have stayed independent. I think they would have done better for everyone. It was going to be a monster company. They could have sold all the medicine themselves. They didn't even need Bristol or Merck, but it's not always easy staying independent. All right, so there's a bunch of other exciting drugs from Bristol Myers. Like a lot of drug companies, they're facing expiry for their bigger drugs, and then eventually the smaller drugs are going to try to kind of compensate for that. But every drug has its life cycle. It's kind of like the circle of life. You really just have to understand that when you're investing in these companies or trying to understand these companies.